My name's Rachel White, and I'm a developer advocate here at Datadog. Welcome to the first video in a new series that's going to explore all aspects of front-end observability and monitoring. Today's video is going to be a high-level overview of the features available to you out of the box when you integrate Datadog's Real User Monitoring into your application, and serves as a walkthrough of the data. Stay tuned for future videos, which will be deeper dives into performance monitoring, advanced configuration and custom actions, error tracking, synthetic monitoring, product analytics, and more. Also, feel free to move through the chapters that the video timeline is broken down into if you're curious about a specific feature, and check out the description for links to documentation, continuing education on this topic on the Datadog Learning Center, and other helpful resources. So, let's start off by learning exactly what is RUM. As traffic and complexity increase, it can be difficult to maintain application stability across versions and browsers without negatively affecting both users and search engine rankings. Real User Monitoring allows organizations to keep load times and errors low by closely monitoring performance and user experience of web and mobile applications in real time. RUM provides a complete analysis of the user journey within web applications, allowing front-end developers to quickly identify, reproduce, and resolve the most impactful issues. You can troubleshoot and resolve front-end errors, specifically JavaScript errors, by pinpointing the root cause of an issue down to the line of code, and identify which segments of your customers are experiencing errors in real time. You're able to collect custom attributes from user journeys and contextualize user sessions on your applications with attributes like user ID, email, and name, and capture business-critical user actions, such as button clicks, taps, and more. Datadog's Session Replay helps identify and fix UX problems faster, as it lets you capture and visually replay your user's web browsing experience for review, analysis, and troubleshooting. So, now that we've got an overview, let's dive in and see how each of those work. To get up and running, we're going to need to set up our application. When you're setting up RUM, you have a multi-step process that begins with choosing the type of application you're wanting to collect data from, whether it be browser or mobile. This initial step is similar depending on what your application type is, and you can choose from JavaScript, Android, iOS, React Native, Flutter, Roku, or Electron. For the overview that we're giving today, we're focusing on browser RUM, so I'll be choosing JavaScript. Once I choose my application type, it's going to give me a few options on automatic user data collection. The first is geolocation data, which gives you information about your users by country, country subdivision, country ISO code, city, and continent. The second is client IP data. Non-selected fields will not be collected. And in case you were wondering, RUM provides controls for implementing privacy requirements and ensuring organizations of any scale do not expose sensitive or personal information. Data is stored on Datadog managed cloud instances and encrypted at rest. The default behaviors and configurable options are designed to protect end user privacy and prevent sensitive organizational information from being collected. If you want to read more about our data security, check out our documentation page linked below, or visit datadoghq.com/privacy. Next step will be to name your application, and then click on Create New RUM Application, which will generate a unique client token. Now we're ready to instrument our application. Depending on which application type you selected in the previous step, Datadog auto-generates code for you so that you can just copy and paste and be ready to go. There might be multiple instrumentation methods depending on your code base, so choose which is best for you. This code is going to include your application ID and client token that we generate, as well as set some parameters regarding sample rates and various tracking. The track user interactions true parameter enables the automatic collection of user clicks in your application. Sensitive and private data contained in your pages may be included to identify the elements interacted with. You can name the environment of your deployed application and set the default name on your service, which will show within the Datadog UI. You're also able to select which sample rate of user sessions you want to capture for the application, and of those user sessions captured, you can set the percentage of those that should include a session replay recording. When choosing these options, we break down the percentages for you so that you're able to see which sessions are just tracking RUM and what is RUM and session replay. There's a session replay privacy setting where you can choose all user input masked by default, so all text in forms is obscured, all text available by default, which does not obscure any data, and all text masked by default, which masks any and all text across your application. Once you've instrumented your application with our SDK and deployed to your environment, we wait for data to start coming in. Once at least one user session is received, your RUM application is enabled and you're ready to begin exploring your data. Let's start with our Sessions Explorer. It's important to understand everything that makes up a user session since it's an integral part of RUM. A user session is a user journey on your web or mobile application lasting up to 4 hours. If a user does not interact with an application for 15 minutes, the session is considered complete. A new user session starts when the user interacts with the application again. A session includes everything a user did. Within that, it could be every single page view, every action they took, which is every button they clicked, any errors that they encountered, any resources loaded on the page, such as images, GIFs, fonts, and long tasks, which is something blocking the UI elements on the page from loading. Everything from views down makes up a session. And from the Explorer here, you can do a lot. You can navigate through user sessions and watch session replays, investigate performance issues affecting views, troubleshoot application errors and long tasks. You can select a visualization for your filters and aggregations that displays your RUM events in a helpful perspective for you to uncover decisive information. For example, you can view RUM events in a list, organize RUM data into columns, see RUM data in graphs that displays your metrics in data over time. You can also create your own custom visualizations and build dashboards out of them. So, let's talk about the different parts of the UI that can help you do that. Up at the top here, you're able to choose from a list of applications that you've instrumented. You're also able to use this drop-down to select which time ranges you're interested in looking at. Next, you choose which type of session data that we're looking through from the first drop-down in the search. And then, for your search query, you can either click from our list of facets, which are broken down by type, or use search syntax, which you can find more information linked in the description below. For a quick example, let's say that we wanted to look at our top page views for the past week. We would make sure that 1 week is selected for our time range. Choose to look at views, and then in facets, search for view path, and click the icon next to it to populate our search query. And then view is a top list. And right here, we can see what is the most popular views out of everything from that time period. Though this is tracking both our organic user sessions and our synthetics tests, so let's filter it a little bit further by typing session type in the facet search and choosing only user. From here, you could save that to a dashboard, so let's go ahead and do that. And then we'll familiarize ourselves with the process. So in this top list that we're viewing in the Sessions Explorer, let's click on where it says Add to Dashboard. We're going to create a new dashboard, name it something helpful to us, and then choose to view it. You can see that it created a new dashboard for us and dropped it right in. From the dashboards page, we can resize our new widget, edit it, tweak the search query, or give it a more helpful name. I'm going to rename it to something that's a little bit more descriptive so that people can tell what they're looking for at a glance. So let's name it Top Page Views. Let's add one more sessions query to our newly created dashboard. We know what the top viewed pages are, but what if we want to see a breakdown of what versions are causing the most errors? We're going to start by choosing to view errors from our dropdown, filter it to just user sessions so we aren't looking at our synthetics tests again, swap our visualization to pie chart, and choose sum of error count by version. You can see it'll break down and give us totals of those errors and what percentage of the total errors that version is causing. So I'm going to save this to the dashboard that we just created, and let's drag that a little bit bigger so we can see some of the pie chart details. Now, just in one place, we're able to see which of our most popular pages are and what versions of our code base are causing the most errors. And this is pretty helpful. But I want to point out one more thing while we're looking at this info. If you hover over a lot of the graphs, you'll see that they're able to be clicked on. Clicking on these visualizations will enable you to get to other parts of RUM to look further into your data and other parts of Datadog. It's really helpful when trying to troubleshoot bugs or issues. Hopefully, you understand a bit more about querying in our Sessions Explorer and being able to save those queries to your own custom dashboard. But if you want to dig deeper on this topic, please check out our documentation guide on getting started with dashboards that is linked in the description below. RUM saves you the time of having to create these custom dashboards though, because of everything that's available to you out of the box once your application is instrumented. So let's walk through page by page and show you how much is available. We'll start with our performance monitoring overview. This page gives you a summary of important performance data from your user sessions. The first being Core Web Vitals. Google's Core Web Vitals are a set of 3 metrics designed to monitor a site's user experience. These metrics focus on giving you a view of load performance, interactivity, and visual stability. Each metric comes with guidance on the range of values that translate to a good user experience. Datadog recommends monitoring the 75th percentile for these metrics. Largest Contentful Paint focuses on load performance, which is the moment in the page load timeline in which the largest DOM object in the viewport, as in visible on the screen, is rendered. First Input Delay focuses on interactivity, which is the time elapsed between a user's first interaction with the page and the browser's response. Cumulative Layout Shift focuses on visual stability. It quantifies unexpected page movement due to dynamically loaded content, for example, third-party ads, where 0 means that no shifts are happening. Next is errors, which are front-end errors. You can see how many errors have happened in the time frame that's selected, and what percentage of sessions occurred with errors. It also gives a top list with the views that have the highest error rate. After errors, we have an overview of deployments. You can see how many active deployments you have, as well as what versions of your deployments user sessions have used. Lastly, on the overview page, we have user analytics, For the time period collected, we're able to see how many total sessions have occurred and what were the most visited pages in those sessions. So now let's look further into each of those sections. You'll notice at the bottom of each one, there's a button that says More, which you can click, but you can also navigate through the items at the top here, which I'll be doing. You can also see that we have one additional section at the top called API. Let's start with the performance page. This page gives us more information on the core web vitals we mentioned earlier, also adding interaction to next paint. INP assesses responsiveness using data from the Event Timing API. When an interaction causes a page to become unresponsive, that's a poor user experience. INP observes the latency of all interactions that a user has made with the page and reports a single value, which all or nearly all interactions were below. A low INP means the page was consistently able to respond quickly to all or the vast majority of user interactions. At the bottom is a performance overview of our top pages. Breaking down each view by name, we see the total sessions and the core web vitals associated. On the right, you can click to view a performance overview dashboard, which gives you a bird's eye view of your RUM application. Something we try to include in a lot of the out-of-the-box dashboards is a summary explaining the contents of the page, which is really helpful when going through everything and trying to make sense of all of the data available. You have an initial overview of page views and loading time, more insight into core web vitals, XHR and fetch requests, as well as resources analysis, which can help you identify bottlenecks when your application loads. And long tasks analysis, which are events that block the browser's main thread for more than 50 milliseconds. The next section after performance is our error summary. This page lets you see the total errors by version of your application, top views with the highest error rate, ongoing issues with details about each issue, the total error count, and volume. The top actions triggering errors, broken down by the action name, which is the user interaction, what view it happened on, how many sessions were affected, and how many total errors happened with that action. Back up at the top, just like our performance overview, we can click into the dashboard to get more context and assess the impact of the application errors. The RUM Web App Errors dashboard helps you focus on the views or versions that are generating the most errors. It identifies code errors so you can get an overview of which parts of your application are generating the most errors, as well as network errors, so you can monitor which resources are causing the most errors. If you want to dig deeper, you're able to head to error tracking to investigate critical front-end errors and learn when new errors appear, which we'll dive into a little bit later. On this page, you can see an overview of the total error rate of your application, which views have the highest error rate, and total errors by version. Next is the error summary. This section covers total error rate, broken down by percentage of views with errors over time, a count of code errors for the time period selected compared to how many errors were occurring in the previous week, and a count of network errors for the time period selected compared to the previous weeks as well. You have a list of error rate by page and a list of actions triggering errors by number of impacted sessions, broken down by action name so you can see exactly what click action occurred, on which view, and how many sessions that error impacted, and the average amount of errors per action for that view. Below that, we have code errors, which breaks down total code errors by type. Source is unhandled exceptions or unhandled promise rejections. Console is console.error API calls. And custom, which are errors sent with the RUM add error API. And code errors by application version. The last section is network errors, with total network errors by HTTP status code, and a list of the top network errors by number of impacted sessions with the resource URL path, what the status was, how many sessions were impacted, and the count of errors. The next section is deployments. First thing is a list of all of your deployment versions for the services selected, what the total amount of sessions were, if there are any active sessions, what new issues are tied to that deployment version, and if there's any Web Vitals P75 warnings. If there are any active sessions by version, total user sessions by version over the time period selected, and error rate by version. Now let's view the dashboard for deployment tracking. This dashboard helps you identify when a recent deployment or release is causing performance issues or new errors within your application. To use this feature, make sure that you add RUM versions to your application, which you can find more about in the link to our documentation page on initialization parameters in the description below. So the overview here gives us the amount of user sessions by version, error count by version, and live user sessions by version. Browser performance metrics shows you loading time by version in the 75th percentile, longest loading time by version in the 75th percentile, time to first byte by version in milliseconds, and longest time to first byte by version in milliseconds. It also has versions by service and view with how many sessions occurred with that version, the average amount of errors per view, and Core Web Vitals P75. At the bottom, there's even more information about Core Web Vitals P75 by version with another summary box reminding you of what each type is. And lastly, on the deployment tracking dashboard is a section on errors. This gives you an error count by version, percentage of views with errors, and a list of ongoing issues with details about the issue, how many times the error occurred, and how many sessions were impacted. Let's go back to the application performance overview again and check out the last section, which is for API-related metrics. The API overview lets you take a look at what resources are causing the most errors and loading issues, whether it be your own API or third-party resources. First, we have a list of the top resource errors, broken down by the URL path group, session total, and total error count, and if there are any failing resources with a status greater than or equal to 400. Then, we have a list of top slowest resources with the median time in milliseconds that it took to call, and a list of top heaviest resources with a median of the amount in KB per resource. Now, let's take a look at the resource overview dashboard. So, once again, we have a summary box about our dashboard. And in the overview section, we have a pie chart of resources by type. Resources by type over time, slowest and heaviest resources. In our most requested resources section, we have a list of the median duration and median size of most requested resources, broken down by resource URL path, resource type, count, load time, and size. We also have a list of pages with the most requested resources by median duration and size, broken down by view name, resource count, resource load time, and resource size. Our XHR and fetch request section shows a bar graph with XHR and fetch requests with a status code of 400 or greater, and a pie chart of XHR and fetch requests with a status code greater than 400 so that you can get a better picture of those requests in total. A XHR and fetch requests repartition graph of total count by type, as well as a pie chart. An XHR and fetch request graph of total count grouped by method, as well as a pie chart. And the resource timing section. It shows you a lot of information about the duration of a resource, which is the total time taken for a resource to be loaded. And that includes DNS lookup, initial connection, time to first byte, and download. More information on resource timing is available in a link to our monitoring resource performance documentation linked in the description below. And the last section, third-party resources. So you can understand which of your third-party resources are having the most impact on your application. You can see resource load times for third-party providers by median load time and 90th percentile load time, listed by resource provider domain and total count. A line graph comparing resource load times for third and first-party providers in the 90th percentile over time, and a pie chart of the share of third-party provider resources. The last section that we're going to talk about under performance monitoring is feature flags, which is currently in beta. Feature flags give you greater visibility into your user experience and performance monitoring by allowing you to determine which users are being shown a specific feature and if any change you introduce is impacting your user experience or negatively affecting performance. By enriching your RUM data with feature flag data, you can be confident that your feature will successfully launch without unintentionally causing a bug or performance regression. You can correlate feature releases with performance, pinpointing issues to specific releases, and streamline data collection and analysis and focus on troubleshooting. Now that we've covered the intro for performance monitoring, let's move on to error tracking. It's critical for your system's health to consistently monitor the errors collected by Datadog. When there are many individual error events, it becomes hard to prioritize errors for troubleshooting. Error tracking simplifies debugging by grouping thousands of similar errors into a single issue. And an issue is an aggregation of error data that provides insights such as how many users have been impacted, when the error first occurred, and which commit probably caused the error. Similarly to the Sessions Explorer, you can browse your errors by choosing a time frame and search by facets. You can also choose whether or not the error caused a crash in your application. You can use these queries to set monitors on error tracking events, such as high error volume or new issues. Clicking on an error to inspect an issue further brings up a panel that provides you even more info. Issues from RUM errors include the stack trace, user session timelines, and metadata, including user location, version, and any custom attributes you included in your crash reports. The last feature of RUM we're going to talk about is Session Replay. Session Replay expands your user experience monitoring by allowing you to capture and visually replay the web browsing experience of your users. Combined with RUM performance data, Session Replay is beneficial for error identification, reproduction, and resolution, and provides insights into your web application's usage patterns and design pitfalls. Session Replay is a part of the RUM Browser SDK, and we also have Mobile Session Replay in public beta for native mobile apps. When using Session Replay, you may have saved some critical replays in a notebook or pasted a session's direct link into a spreadsheet so you could revisit it during an investigation. While helpful, these methods of saving session replays are a temporary fix. They're difficult to scale, force context switching, and don't really provide a convenient or collaborative experience. Notebooks and spreadsheets also lack the flexibility to help you identify themes or patterns that may arise from your session replays. This information is crucial to understanding UI performance and significantly accelerates finding the root cause of UX errors. To bridge those gaps, we've created playlists. You can efficiently group and organize your session replays, which are easily shareable and designed to help you and your team further streamline your troubleshooting and debugging workflows. Let's take a look at search recordings, which conveniently shows all of your session replays and recently created playlists in one place. By default, the search recordings page shows the sessions most interacted with, the sessions with the most errors, and the sessions with the most frustrations. But it also allows you to filter by keyword, time spent, browser name, and other options. These filters give you quick access and insights so you can create playlists that coincide with the key behavioral patterns emerging from your UX. Let's view a session now. You can get to session replay from multiple pages within RUM. You'll know that it's available if you see this round play button. When taking a look at a user session, we give you a lot of valuable information in one place. You'll notice that we have the Dev Tools button selected, which toggles our built-in debugging tools to help you troubleshoot your applications. I'm going to go ahead and hit play on this session and tell you about what we're seeing. On the right is information about the individual user and the environment that they're viewing, as well as geolocation and system details. You're also able to generate a synthetic browser test based off of the user's session. And then you're shown a timeline of RUM events that were a part of this session. You'll see that as the timeline plays, it moves us through each event. You can also click on each event to jump to that point in the session in the player, as well as click on more details to open the side event panel if you're trying to get more information. In the bottom section, you have a few options to choose from, including performance, which shows you a waterfall of events, such as actions, errors, resources, and long tasks, and timestamps in the session. Console, which shows you all the logs collected from the web browser and errors for each view. Errors, which displays RUM errors and error tracking issues that correlate to the session. And lastly, attributes, which is detailed information about the application, user, session, view, and custom attributes. And that's all for today, and we barely touched the surface on all of the things that you can do with RUM. You'll notice as I talked about different features today that there's more than one way to navigate through all of the sections to make sense of your data. What it all comes down to is knowing how to narrow down the key points in your user journey for the particular use case that you're looking at. I hope that today served as a good walkthrough of what exactly is available to you. Stay tuned for more videos and deeper dives into front-end observability and monitoring, and check out the description below for helpful links to all of the topics that we covered today.